Hello everyone, welcome to Dakshana e-classroom program. In today's lecture, I am going to talk about the solution to last 20-year IIT questions asked in from chapter Wave Optics. So before starting the questions and solution, let me tell you few things about the IIT and wave optics chapter connection. So first thing is that this wave optics chapter, it's very important from IIT point of view. You will see that almost every year IIT asks questions from this chapter. Another important point about this chapter is that this chapter is very small. If you just look for the theoretical part, then it within 10 to like around 8 hours, 6 to 8 hours, you will be able to finish the theory of this chapter. And beside that, like because it's very small chapter, you're able to finish the theoretical part very easily and like in very small interval of time, and small, and it's equally more important actually, because you will see that almost every year, I mean like there are very few year where IIT has not asked some questions from this chapter. Otherwise almost every year IIT asks questions from this chapter. Yes, it's right that actually in 2020 is it or 2020 no question is asked from this chapter, but in 19 also questions are asked, and before that also. So we will see like it's like quite very important. And theory, if you look for it and if you understand things properly, I don't think you will find it even very difficult also, because here the concepts are quite easy if you understanding it properly. So it's like very important chapters. Pay attention, learn it properly. It's like a rewarding point for you and plus point. Okay, so let me start with the solution. This is the first question which is asked in 2019. The question was asked in 2019. Okay, so the question is, in Young's double slit experiment, the slit separation D is this D is 0.3 mm and screen distance capital D is 1 meter. A parallel beam of light of wavelength 600 nanometer is incident on the slit at an angle alpha as shown in the figure. On the screen, point O is equidistant from the slit and distance PO is 11 mm. Which of the following statement is are correct for alpha this? So क्वेश्चन सिंपल सा ये है, ये हमारे पास एक YDIC का सेटअप दिया गया है where a ray is it parallel beam is incident, but it's an incident at an angle alpha with this axis, right? And this slit S1 and S2, the separation between slits is small d and it's given small d is 3 mm. O is the center of screen, and screen is placed at a capital distance which is equal to 1 meter. P is one point on the screen and this distance is also given to you. This is 11 mm. So this is the information, and for different values of alpha, so here we are given some options and we need to check which is right. Okay, so alpha value here, it's like given in this, and we need to take actually in different case different values of alpha. So in general terms we can understand like what exactly we will check every option and then we will comment whether which one is right or wrong. So question overall, if you just look at it and if you are very well aware with the theory, then you should find it very easy actually, because it's not difficult at all, right? But let me solve it. Okay, so if D is the separation, we know actually this is from which topic in a wave optics, it's oblique incidence case of YDIC setup, right? So in case of oblique incidence, the path difference in general term, I can write the path difference is it, if I write for point, let's say P, path difference for point P, then I can write delta x is equal to what? D sine alpha plus D sine theta for a small value of theta, and this you can write D sine alpha plus sine theta. This can be also written as actually D times alpha plus theta when theta and alpha both are small, only in that case. And for point O means that is also called central maxima. We can write delta x is equal to, for point O, because it's equidistant from S1 and S2 slits, so that's why there will be only this is the path difference. So that can be written as d sine alpha, right? Okay, now let me check the option 1. For alpha is equal to 0.36 by pi degree, is it? So option A, alpha 0.36 by pi degree, and that is equal to 0.36 multiplied by pi divided by pi multiplied by 180 degree. That comes out to be 1 by 500 radian. So this is the angle. Now there will be destructive interference at point O. So let's check what is the path difference for point O. If it is a multiple of lambda, then at O there will be constructive interference. If lambda, path difference for point O comes out to be multiple of lambda by 2, it will be a destructive interference. So we can check the path difference for O, is it, in this situation. So delta x is equal to d. D is coming out to be how much? 3 into 10 to the power minus 3 mm multiplied by sine theta alpha, and sine alpha for small value of alpha can be written as 1 by 500. And let's say this is equal to n into, or let me just simplify it further. So this comes out to be how much? 3, or I can write 30 divided by 5 into 10 raised to power how much? This is 3 and it's like minus 6, and it comes out to basically 6 into 10 raised to power minus 6, or it can be written as basically 6000 into 10 raised to power minus 6. You can write it's a nanometer, 6000 nanometer. So you can see actually here 6000, and what is the wavelength? Lambda is equal to 600 nanometer. So definitely this is what you can see for point O, delta x is equal to n lambda. So that means at point O there will be constructive interference, not destructive interference. So first is not right, is it? It's wrong statement. Fringe spacing depends on alpha, and we know actually for point B means fringe spacing means beta, is it, fringe width. We know it's equal to lambda capital D by small d. Does it depends on angle alpha? It's saying fringe spacing depends on alpha. No, it's not. It doesn't depend on alpha. Okay, so similarly for for alpha equal to this degree, there will be a destructive interference at point P. So let's check the condition for point P also. So I can erase this part, and we got actually for point P the path difference is coming out to be this, and that can be, so let me write, this is for option C. So delta x is equal to d alpha plus d theta, and this value I already know, it's coming out to be 6000 nanometer. Let's check this d into theta. So d is 3 mm, 3 multiplied by minus 3 into theta. Theta is how much? For point, okay, d sine theta. Alright, so for this case the sine theta can be written as basically equal to tan theta, and tan theta will be equal to 11 into 10 raised to power minus 3 divided by capital D, right? So then rearranging it, it comes out to be how much? I can rearrange it. So this is equal to 6000 nanometer plus this will be like 33 into 10 raised to power minus 6, and this is equal to 6000 nanometer plus this is 33,000. if I write it into 10 raised to power minus 9, then that will be also nanometer. So it's coming out to be basically 6,000, 33,000, 39,000, right, into 10 raised to power minus 9. And let me check it. This is equal to n into lambda, whether it's multiple of lambda by 2 or lambda, because here saying of there will be destructive interference at point P. So P, it's n into lambda is equal to how much? Lambda is equal to 600 into 10 to the power minus 9. Minus 9 gone, and this is also gone. So n is coming out to be 390 divided by 6, right? And that is 1 3. I think I missed 1 0 actually. 6000, it's like 10 is power, okay, just let me check the calculation. It comes actually 13 by 2, so that comes out to be actually 6.5. I just missed 1 0 actually. So minus 9, it will be like, it should cancel out actually, and then that's for minus 9 minus 10 gets cancelled, and solving it actually here 1 0 is coming. I am just missing that in calculation, you check for it. So n comes out to be actually 13, this is 39 by 6, 13 by 2, that is 6.5, and that is equal to how much? So that means it's basically 13 by 2, is it? That is means it's a multiple of lambda by 2. I hope you are getting. This can be expressed as, so the path difference delta x for P is equal to how much? You can write 2n plus 1 into lambda by 2, where n is equal to how much? 6, right? And when delta x is multiple of lambda by 2, in that case there must be perfectly destructive interference. So it's saying for alpha equal to this degree, there will be destructive interference at point P. This is correct. You just check the calculation part. For alpha equal to 0, there will be constructive interference at point P, is it? So for alpha is equal to 0, then we can write there will be like this is n lambda. Okay, let me just erase it, erase this part. So next part, point D, for alpha equal to 0, that means delta x for point P, is it? For point P, delta x will be what? D alpha plus d theta. This is becoming 0, so it's only d theta, and we can say d alpha is what? Multiple of lambda, and this is what? Multiple of lambda by 2. So it's saying constructive interference at point P. You can write d theta delta x is equal to d theta is equal to you can write odd multiple 2n plus 1 into lambda by 2, because we have already checked it, right? So that in this implies at P for alpha equal to 0 will be destructive interference. And it's saying constructive interference, so this is also not right. So that is the problem, and it's easy problem actually. Yes, you need to check for it every option whether it's right or wrong. Let's see the next question. Okay, so the next question here, it was asked in 2017 in paper 2. The question is, let me read it. Two coherent monochromatic point sources S1 and S2 of wavelength lambda 600 nanometer are placed symmetrically on either side of center of the circle. So S1 and S2 are two monochromatic coherent point sources placed symmetrically to the center of circle. So this is the center of circle, so they are placed symmetrically like this, and the sources are separated by a distance d, small d, that is equal to 1. Small d is mentioned as 1.8 mm. This is the separation between sources. This arrangement produces interference fringe visible as alternate bright and dark spot on the circumference. So this arrangement is producing actually alternate bright and dark spots on this circumference of circle. This setup, this system is not new to us. We have already discussed or seen this type of setup in our video lectures based on wave optics. So we are very well familiar, and you must be even remembering that actually this is one of the setup where like YDSE can be observed on the circumference of this circle. Okay, so this arrangement produces interference fringes visible as alternate bright and dark spots on the circumference of the circle. The angular separation between two consecutive bright spots, that is delta theta. Okay, which of the following options are correct? Dark spot will be formed at point P2. At point P2, the order of fringe formed will be maxima. Total number of fringes produced between P1 and P2 in the first quadrant is close to 3000, and delta theta means this same angular separation between two consecutive bright spots decreases as we move from point P1 to P2. So these are four options. We need to check कि कौन सा इनमें से सही है, कौन सा गलत है. So first thing is मेथड. यू मस्ट बी वेरी वेल अवेयर कि यहाँ पे एक्चुअली में क्या है, कैसे YDSE सेटअप है, कैसे चीज़ें यहाँ पे लाइक दो सोर्सेज से इंटरफेयर करती हैं, लाइट और रेज, एंड हाउ दे आर फॉर्मिंग ब्राइट एंड डार्क स्पॉट. सो फ्रॉम द इंटरफेरेंस फेनोमेना वी कैन सी हियर सिंपल थिंग इज the rays traveling from two sources S1 and S2 will differ by some path difference that will result in phase difference, and when some phase difference is multiple of lambda, there will be constructive interference, and if it is multiple of lambda by 2, there will be destructive interference. So now see, at point P1 the path difference, because rays coming from both the source S1 S2 will be traveling same path, is it? So I can write at P1 delta x will be 0. What will be that? It is a maxima, and when delta x is 0, we call it central maxima, is it, or zeroth order maxima. So it's zeroth order maxima. Another thing, if I talk about general point, let's say P, then at this point let me draw the diagram another. So for general point P, if these are two sources, let's say this, the path difference, because here यहाँ पे ये जो D है वो आपको रेडियस के काफ़ी कंपेरेबल साइज में दिख रहा है, बट इन प्रैक्टिकल एक्चुअली सिचुएशंस दिस स्मॉल d इज वेरी स्मॉल और वेरी स्मॉल कंपेयर टू दिस रेडियस. सो इन दैट केस वी कैन टेक दिस बेसिकली like small d is very small. So in this situation I can take, let's say these two rays are almost parallel, तो उस कंडीशन में हम लिख सकते हैं जो पाथ डिफरेंस होगा between these two rays, because this is almost parallel, this is almost parallel, so this part is equal to this, तो ये अपना पाथ डिफरेंस आ जाता है. तो अगर ये स्मॉल d है, ये एंगल थीटा, तो इसको भी अपन थीटा लेते हैं, एंड वी राइट डेल्टा x इज इक्वल टू d cos थीटा, राइट. तो अभी पाथ डिफरेंस आ गया d cos थीटा. यहाँ पे देख सकते हैं थीटा की वैल्यू क्या होगी, 0, थीटा वैल्यू 90 डिग्री, दैट विल बी पॉइंट P1, तो पाथ डिफरेंस अपना 0 हो जाएगा. और यहाँ से हम देख भी सकते हैं कि इस पॉइंट पर जब ट्रेवल करेंगे तो एग्जैक्टली ये पाथ डिफरेंस क्या आ जाएगा, सीधा d के बराबर आ जाएगा. सो फॉर थीटा इक्वल टू 0 मीन्स आई कैन राइट फॉर पॉइंट P2 you can write theta equal to 0 and delta x is equal to d cos 0 means d. ये चेक कर लेते हैं पहले, ये मल्टीपल ऑफ लेमडा है या लेमडा बाई 2, तो उसके हिसाब से P2 पॉइंट पे either it will be having maxima और minima. So this is equal to n lambda, तो यहाँ से n is equal to, this is 1.8 into 10 to the power minus 3 divided by lambda is 6000 into 10 to the power minus 9, and this comes out to be 2, so it's 7 and 6 power minus 6 and then 3, so 18 into 10 to the power 3 divided by 6, that comes out to be 3000. So what it mean, n is coming out to be 3000, so means n is a what, integer, right? So this implies P2 will have bright spot, constructive interference, and order of maxima will be 3000, right? So here there will be 3000s number of maxima, order of maxima will be 3000. This is, and let's check the options now. And another thing we can see here, for general point I can write the delta x is coming out to be how much, d cos theta, I mean like delta x is equal to d cos theta. For bright spot, I can write this should be equal to n lambda, right? And delta theta, so we need to check actually delta theta. So let me come to that point. First, a dark spot will be formed at point P2. So at point P2 we are getting theta equal to 0, delta x d, and we are solving, we are getting 3000. Means number of like path difference at point P2 is 3000 lambda. So that means there will be a bright spot actually, not dark spot. Means first is not right statement. At point P2 the order of fringe formed will be maximum. Yes, that also you can see. क्योंकि यहाँ पे देख सकते हो जो P1 है उस पे क्या हो रहा है, ऑर्डर ऑफ फ्रिंज फॉर्म हो रही है, वो 0th ऑर्डर है, लोएस्ट वन. यहाँ से जैसे जैसे हम जा रहे हैं तो इस पॉइंट पे अपन ने देखा वहाँ पे क्या हो रहा है, ऑर्डर 3000 वाला है. सो दैट्स वाई यस इट्स आल्सो करेक्ट. द एट पॉइंट P2 order of fringe formed will be maximum. Correct. Total number of fringes produced between P1 and P2 in the first quadrant is close to 3000. This is also correct because यहाँ पे 0th order है, यहाँ पे 3000 order है, तो total like it will be close to 3000 order like number of fringes. This is also right. Delta theta angular separation. So first let's calculate what is delta theta, right? Delta x we got it. Let's differentiate it. तो यहाँ से क्या आएगा, d differentiation of cos theta is minus sin theta into differentiation of theta is d theta equal to, this is delta n into lambda. Delta n is the, delta theta is the angular separation, delta n is the number of fringes changing, is it? So delta theta divided by delta n fringes will be the angular separation per unit fringe, is it? So this comes out to be, this implies delta theta or d theta divided by del, let me write it simply in terms of delta. So this is delta, so delta theta divided by delta n is equal to lambda divided by minus of sin theta, right, divided by d. Now you can check it. So this is the exactly what we needed actually here, angular separation between two consecutive bright spots. Now so here lambda is constant, small d is also constant. As we are moving from P1 to P2, let's check what is happening. So for point P1 sin theta is what, maximum 1. So means this quantity will be what, lowest. And as we are moving from P1 to P2, sin theta value will keep on decreasing because at P2 it will be having like how much, 0. So 0 means this angular separation will be maximum. So now as we can see, when we are moving from P1 to P2, this quantity, is it, you can multiply it delta n also. So delta theta is equal to delta n, this is lambda divided by मैग्नीट्यूड से अपन को यहाँ पे मतलब है, तो मैं मॉड के लिए अगर देखूँ तो ये साइन थीटा इंटू 1/d. तो यहाँ पे देख सकते हैं कि डेल्टा एन को मैं एक ही लिख देता कर देता हूँ, तो उस केस में जो डेल्टा थीटा है, राइट, फ्रिंज एंगुलर सेपरेशन बिटवीन टू कंसेक्यूटिव ब्राइट स्पॉट्स, वो साइन थीटा के इन्वर्सली प्रोपोर्शनल है. और जब P1 से P2 मूव कर रहे हैं तो साइन थीटा की वैल्यू घट रही है, तो इसलिए ये थीटा की वैल्यू क्या होगी, बढ़ेगी. ये क्या कह रहा है ऑप्शन, डेल्टा थीटा एंगुलर सेपरेशन बिटवीन टू कंसेक्यूटिव ब्राइट स्पॉट डिक्रीजेस as we move from point P1 to P2 along the first quadrant. So this is also definitely wrong statement. So this is all about the problem, and it was asked in 2017 advanced paper 2. I hope you understood this concept and problem. Okay, so the next question here, it was asked in 2016 in paper 2, and the earlier question was asked in 2017. 18 was missed, 19 question was also asked, similarly 15 also asked. So you can see actually almost in every year question is asked from actually this chapter. Okay, so first let's see the question. While conducting YDSE Young's double slit experiment, a student replaced the two slits with large opaque plate in the XY plane containing two small holes that act as two coherent point sources S1 and S2 emitting light of wavelength lambda 600 nanometer. So here, while conducting the YDSE setup experiment, a student replaced the normal setup with a like opaque sheet, and which is placed in XY plane. So this is XY plane like this, and two holes are there in that sheet, which, and these two holes are acting like a coherent source, two coherent sources which are emitting light of wavelength 600 nanometer. The student mistakenly placed the screen parallel to XZ plane for Z equal to 0. Okay, so student has placed by mistake screen parallel to this parallel to XZ plane. So this is XZ plane parallel to it, and for Z greater than 0, so means there is no screen here, but screen is there for Z greater than 0. And at a distance capital D equal to 3 meter from midpoint. So capital D is the distance from midpoint of S1 S2 to the screen that is placed at origin, and that is given as capital D is equal to 3 meter from midpoint of S1 S2. Distance between sources, that means small d, is this, is given as 0.6003 mm. The origin O is at the intersection of the screen and screen at the line joining S1 and S2. Line joining S1 and S2 this, and screen, this intersection point is marked as origin. Okay, that is also clearly mentioned. Line joining. Okay, which of the following is true of the intensity pattern on the screen? So first thing is, this is also another setup, another way of performing YDSE setup, and normally in class we discuss this setup also. So first thing is, you should understand actually how interference is happening here, how this setup actually perform YDSE. So just try to imagine here, this is a basically your screen, and here you can see this is the, let's say, screen. Okay, let me write, this is according to this diagram, this will be X, this is your Z, and your Y direction is Y is inward, right? So this is the screen, and basically screen is placed only for Z greater than 0. So this is screen, and here this is the line Y axis. On this line actually two sources are placed, one is here, another here, and there is basically opaque sheet, so means no light is going down. Screen is placed only here, means we are observing the setup or system fringes only on this screen. Okay, so first thing is, just try to imagine it. From here along the y-axis I am placing one source, let's say here S2, another source here S1. Now from these two sources light will be reaching like this at some point, is it, on the screen, depending on, so you can see, just imagine this is, let me take it to some point midpoint. Then if I'm taking any point here, is it, let's say distance r, right? Then what can be written as r is equal to, this is what, xz plane, so r can be written as under root x square plus z square. I hope you are understanding this. And the distance of this point, so this point will be somewhere on this screen, which is from distance r from the origin. If you are looking at from this side, is it, then ये screen आपको ऐसे पेपर दिखेगा, तो ये screen पे ही कहीं point यहाँ पर है, right? तो वो point अपना ये मैंने मान लिया r distance पे origin से, तो r को मैं ये लिख सकता हूँ और ये point मेरा इस तरह से दिखाई देगा. अब ये देखो, पहली बात तो इस पॉइंट की अगर मैं बात करता हूँ, तो इस पॉइंट के लिए जो डिस्टेंस पाथ डिफरेंस आएगा, दिस, इसको अपन थीटा ले लेते हैं, दिस इज थीटा, पाथ डिफरेंस इज इक्वल टू दिस, एंड जो कि बराबर होता है डी कॉस थीटा के, राइट? इस तरह के सेटअप में, सो डेल्टा एक्स इज इक्वल टू डी कॉस थीटा, एंड कॉस थीटा विल बी इक्वल टू व्हाट? अगर मैं ये टोटल डिस्टेंस पूरी कुछ यहाँ से ये ले लेता हूँ, तो ये डिस्टेंस दिस डिवाइडेड बाय दिस बेस, राइट? सो दिस कैन बी रिटन कैपिटल डी डिवाइडेड बाय अंडर रूट, ये डिस्टेंस r है तो r स्क्वायर प्लस कैपिटल डी स्क्वायर, दिस इज कॉस थीटा. सो डेल्टा x कैन बी रिटन एज स्मॉल d कैपिटल T डिवाइडेड बाय, this is under root r square plus capital D square, and to have at point r send like maxima, this should be equal to n lambda. थोड़ा सा इसको रीअरेंज कर देते हैं. So small d capital D n lambda, is it? If I'm fixing this n, then what one particular n, this will be constant, and let me square it. This is equal to r square plus capital D square, और r स्क्वायर की वैल्यू मैं ये रख देता हूँ, then it's x स्क्वायर प्लस z स्क्वायर plus d square, and this implies d square is also constant, x square plus z square equal to something this, or I can write it d by n lambda, is it, whole square minus 1 into capital D square. This is something constant, let me write it, c square. So what I am getting actually, it's x square plus z square equal to c square. This is the equation of circle which is centered at 0, 0, and the circle is lying in the plane of xz. You must be familiar with this. ये आपको समझ में आ रहा होगा from this equation. अब देखो, एक तो तरीका है कि आप इसको थोड़ा सा फिजिकली फील करके इमेजिन करें कि सिचुएशन हो क्या रही है. ये जो स्क्रीन है, अगर आप इसको सामने से इधर से देखेंगे, ये जो स्क्रीन है ऐसे, उसको इधर से देखेंगे तो ये स्क्रीन आपको ऐसे दिखाई देगी. ये जो लाइन है वो आपके लिए पॉइंट हो जाएगा, दिस इज योर वाई एक्सिस गोइंग इनवर्ड. तो ये एक्स एक्सिस जो इधर बाहर आ रहा है अभी एक्स, और ये ऊपर, तो ये एक्स जेड प्लेन हो गया. अब ये जो पॉइंट है हमारे दो सोर्सेस वो ऐसे हैं, यहाँ पे एक ये S1, ये S2, यहाँ से लाइट जा रही है किसी पॉइंट पे, तो ये पाथ डिफरेंस आ रहा है, और अपन ने देखा एन लैम्डा के लिए तो वो अपना एक सर्कल आ रहा है, राइट. सो डिपेंडिंग ऑन कि अगर ये एन लैम्डा का मल्टीप्लाई है, देन वी विल हैव ब्राइट स्पॉट एंड दैट विल बी अ सर्कल. अनदर पॉइंट हियर कि अगर ये पूरी स्क्रीन एक्स जेड प्लेन में प्लेस की जाती तो ये सर्कल कंप्लीट होता, लेकिन क्योंकि ये स्क्रीन ओनली फॉर जेड ग्रेटर देन 0 है, तो ओनली ये वाला पार्ट ही दिखाई देगा, एंड दैट विल बी अ सेमी सर्कल. और इसके हिसाब से हम आंसर कर सकते हैं. सो लेट्स लुक एट इट. हाइपरबोलिक ब्राइट एंड डार्क बैंड्स विद फोकाई symmetrically placed about O in the x direction. So definitely you can check it's not at all matching. There is no hyperbola, no hyperbolic bright and dark bands. It's only semicircular or circular. Semicircular bright and dark bands centered at point O. You can see here, this is a semicircle, I mean like circle actually, but because screen is only for z greater than 0, that's why it will be a semicircle, and the center of this semicircle will be at origin. So this means B is your absolutely right statement. Region very close to point O will be dark. Let's check for it. Straight bright and dark bands will be parallel to the x-axis, so definitely this is also not right. अभी ये आपको समझ में आ जाना चाहिए कि यहाँ पे अपन ने किसी भी जनरल पॉइंट पे क्या है, कैसे अपन ने कंसिडर किया, और हमें जो फ्रिंज पैटर्न बनेगा उसका हमारे पास एक इक्वेशन भी आ जाता है, एंड दैट्स क्लियरली मेंशनिंग, क्लियरली टेलिंग यू इट विल बी ए सर्कल, एंड बिकॉज द प्लेन इज हाफ, दैट्स व्हाई इट विल बी ए सेमी सर्कल. अभी चेक करते हैं जो पॉइंट O है उस पर ब्राइट स्पॉट आएगा या डार्क स्पॉट आएगा. सो फर्स्ट थिंग इज फॉर पॉइंट O द सेपरेशन, बिकॉज थीटा विल बी व्हाट, 0, राइट. लेट मी रेज दिस पार्ट. So D option for point O, you can write theta will be equal to what, 0. So delta x is coming out to be simply D. और ये D की वैल्यू कितनी दे रखी है, ये अपन को दे रखी है, दिस इज D. So मैं इसको लिख सकता हूँ 6003 into 10 to the power minus 4 into 3, 7 meter. Clear? And D delta x should be equal to, let me check it, n lambda. If n is integer means bright spot, if n is fraction or half, is it, then it will be a dark spot. तो check कर लेते हैं. So this n lambda equal to 6003 into 10 to the power minus 7 divided by its 6000 into 10 to the power minus 9. Clear? So then we are getting it n is it? Or we can check for even like delta phi also, is it? It will be easier whether delta phi is coming out to be. So this is delta x. All right, let me check it. So this is equal to how much? 10 to the power minus 7. It's left with the 6,003,000 divided by 600, right? And this 0 gone, and if I am dividing by 3, then it's 2. This is 2001, right? And you can check it, actually n is not exactly coming out to be, it's 2001 by 2, and that's equal to 1000 plus half. So this also you can see, it's what, odd multiple. I'm like, it's not even, I'm like multiple of lambda, it's multiple of lambda by 2. N is 1, I'm like something integer plus half. तो यहाँ से भी क्लियरली हमें समझ में आ रहा है, इसका मतलब पाथ डिफरेंस क्या आ गया. सो डेल्टा एक्स इज इक्वल टू व्हाट, you can write this is 2n, means 2n plus 1 by 1 into lambda by 2, and here it's coming out to be how much, n is equal to 1000. So this is a lambda by 2 multiple. So that's why O point will have what, dark spot. And what it's saying, the region very close to point O will be dark. That is also correct. The right answer to this problem is B and C. यहाँ पे देखो चीज़ें बस क्या है, एक YDSI का ही अलग सेटअप है, बट ये सेटअप नॉर्मली हमें क्लास में डिस्कस किया जाता है, तो आपको बहुत आसानी से हिट करना चाहिए कि क्या है अप्रोच, कैसे सॉल्व करना है, कैसे अप्रोच करना है, because you should be able to imagine this situation actually by just looking at this problem, is it? And if you have not seen this type of model in the class or not studied, then I can just imagine it will be a little bit difficult for you to imagine this question when you are looking at it first time, is it? But still it's not very difficult question. So you can say this question was asked in 2016 in paper 2, and I hope you understood this problem also. Let's see the next one. Okay, so the next question here, it was asked in 2015 paper 2. The question is 4 harmonic wave of equal frequencies. It's clearly mentioned frequency is equal, frequency F equal, and intensity, equal intensity I naught also, have phase angle 0, pi by 3, 2 pi by 3 and pi. When they are superposed, the intensity of resulting wave is n I naught. The value of n is, so this is a basically like problem based on superposition principle. And here if I say the 4 waves are y1, y2, y3 and y4, and their phase angles, is it? So here it's 0, it's pi by 3, it's 2 pi by 3 and it's pi, right? If I just simply draw their phase, is it, or displacement on phasor, then it's basically y1, y2 will be here at angle phase pi by 3, and y3 will be here at angle 2 pi by 3, and this is y4. And because यहाँ पे आप देख सकते हो intensity is equal, so that's why I can write amplitude will be also equal. Also equal, because intensity is directly proportional to amplitude square. Intensity is equal, that means amplitude will be equal. And now when these 4 waves superposed, is it, superimposed, what will be the resulting? So here you can see this 1 and 4, they are exactly out of phase, so means they will simply cancel each other. Now what we are left? We are left with only y2 and y3. And here when 2 waves are superimposing, and what is the phase angle between these two? That is equal to pi by 3. And is it, by superposition principle we know actually I intensity is equal to I1 plus I2 plus 2 root I1 I2 into cos of phi, where phi is the phase angle between I1 and I2, or you can write phase difference between two waves, right? And here we are left with only 2 and 3. तो यहाँ पे देख सकते हैं इन दोनों के बीच में फेज एंगल कितना है, फेज डिफरेंस कितना है, π/3. इंटेंसिटी इसका भी I0 है और इसका भी I0 है, तो मतलब I1 I2 दोनों इंटेंसिटी I0 है. अभी इसमें रख देते हैं. सो I इज इक्वल टू I0, I2 इज आल्सो I0 प्लस 2 I0 cos π/3. क्लियर? सॉल्व करते. I0 इन दोनों को ऐड करके इट्स 2I0 प्लस 2 एंड रूट I0 मीन्स I0 cos π/3 60 is equal to 1/2, and this implies it's 3I0. So intensity is coming out to be 3I0. Comparing this result with this expression equal to nI0, this implies the value of n is coming out to be 3. Now this is the answer to the problem, and you can see it's simple, straightforward problem based on superposition principle. You need to check actually, क्योंकि यहाँ पे 4 you are given with 4 waves and it become very difficult actually if things are not cancelling out. So it's better to look at it these waves by like phasor diagram basically, or draw all those waves on phasor with phasor angle. तो इक्वल अगर दो वेव्स हैं जिनमें फेज एंगल या आउट ऑफ फेज हैं, देन दे विल सिंपली कैंसल आउट. रिमेनिंग टू यू कैन go for it the calculation part, and that's what we are getting straightforward answer and coming out to be 3. Let's see the next question. Okay, so next question here, question number 5. It was asked in 2015 paper 1, and let me read the question first. So here a Young's double slit experiment, slit interference arrangement with slit S1 and S2 immersed in water. So this is the actually experiment setup for Young's double slit. S1 slit and S2 is immersed in water. So here there is water actually, and on the top it's air. The position, water refractive index is given 4/3 as shown in the figure. The position of maxima on the surface of water are given by this. So the position of maxima are given by this expression, where lambda is the wavelength of the light in air, refractive index 1, and 2d is the separation between the slits, and m is an integer, and find the value of p. So this is the question, and now we need to solve it. So यहाँ पर भी देख सकते हैं कि अगर आपको क्वेश्चन समझ में आ रहा है then it's not difficult. ये आपको easily strike करना चाहिए कि यहाँ पे क्या करनी है चीज़ों को. थोड़ा सा जो ध्यान रखने वाली बात यहाँ पर ये है कि अगर मैं ये जो पॉइंट ले रहा हूँ at distance x, if let's suppose t, जिसको मैं लिख सकता हूँ equal to what, x square plus small d square. अगर ये डिस्टेंस जो s1, मैं इसको पॉइंट p ले लेता हूँ, तो s1p is equal to x एंगल t, एंड जो कि ये है, तो s2p भी अगर ज्योमेट्रिकल पाथ देखा जाए that is also equal to t, but it's in refractive medium is different of refractive index mu. Geometrical path s2p is also equal to t, but its equivalent optical path for s2p, I will write optical, that will be equal to how much, mu into t, and mu is equal to mu water 4/3. तो यहाँ पे जो पाथ डिफरेंस, अब ये ध्यान रखने का कि जब अपन ने ये ज्योमेट्रिकल पाथ के इक्विवेलेंट पाथ ले लिया, तो अब ये क्या होगा, this system s2p will be equivalent to what, this much path difference, and in air not in water. तो path difference जो effectively आएगा, the path difference for point P, so that you can write S2P optical minus S1P this is delta x. This comes out to be mu water into T minus T, that is mu water minus 1 into T. Mu water की वैल्यू अगर रख दिया जाए तो it's coming out to be T by 3. And this path difference at this point there should be what? It's clearly mentioning maxima, is it? The position of maxima. So this implies I can write delta x, that is equal to T by 3, and T is under root x square plus d square by 3, which is equal to what? M lambda. Let's simplify it, multiplying it and squaring it both sides. X square d square is equal to 3 square m square lambda square. Rearranging it further, x square is equal to 3 square m square lambda square minus d square. Compare this result with this expression. What we are getting the value of p. This implies, comparing the result, p is coming out to be 3. The answer to this problem, the value of p will be equal to 3, and this is the question. तो यहाँ पर जो थोड़ा सा चीजें समझने वाली थी वो ये थी कि p पॉइंट का अगर देखा जाए तो ज्योमेट्रिकल पाथ s1p and s2p दोनों एग्जैक्टली सेम है, बट बिकॉज s1p जो पाथ वेव ट्रेवल कर रही है वो एयर में है, s2p ट्रेवल कर रही है वेव वो वाटर के अंदर है, तो उसकी वजह से जो ज्योमेट्रिकल पाथ आएगा दैट आई लाइक इट विल बी सेम बट ऑप्टिकल पाथ विल बी डिफरेंट. तो हमें ऑप्टिकल पाथ लेंथ इक्विवेलेंट निकाली, फिर ऑप्टिकल पाथ लेंथ माइनस दिस ज्योमेट्रिकल पाथ इज एक्चुअली योर पाथ डिफरेंस और इफेक्टिव पाथ डिफरेंस. हाँ, बिकॉज इट्स सेइंग द कंडीशन ऑफ मैक्सिमा, तो अपन ने क्या किया, सिंपली ये जो पाथ डिफरेंस आया mu 4/3 minus 1, it will be t by 3, t की वैल्यू here रख दिया, and this should be equal to what? M lambda. M is integer, means integral multiple of lambda for maxima. Simplifying it, we are getting this expression. इसको अगर आप कंपेयर कर रहे हैं तो सॉल्व करके अपने पास ये आंसर आ जाएगा, and this is the problem. So I hope you understood this. Okay, so next question here, question number 6. A light source which emits two wavelength lambda 1 and lambda 2, 400 and 600 nanometer is used in YDSE if recorded fringe width for lambda 1 and lambda 2 are beta 1 and beta 2 respectively, and number of fringes for them within a distance y on one side of the central maxima are m1 and m2 respectively. Then we need to check the correct option, beta 2 greater than beta 1, m1 less than m2, and from central maxima third maxima of lambda 2 overlap with fifth minima of lambda 1, angular separation of fringe width lambda 1 is greater than lambda 2. So let's check it. So lambda 1 is 400 nanometer, lambda 2 is 600 nanometer. First it's talking about fringe width that is equal to beta, and we know it's equal to lambda d by capital D by small d. So capital D and small d both are remaining same, and here it's clearly mentioned lambda 1 here, yes, so lambda 1 is less than lambda 2. What it implies, beta is directly proportional to lambda, so that means beta 1 is less than beta 2. And what is the first option? So beta 2 is greater than beta 1. First A is right. Next is m1 and m2, and it's saying number of fringes for them within a distance y. So number of fringes within a distance y. So y, m equal to what? Y divided by beta. Y is constant. This implies m is inversely proportional to beta, right? Or I can write beta into m equal to constant. This implies m1 beta 1 should be equal to m2 and beta 2. And here beta 2 is greater than beta 1. What it implies? As beta 2 is greater than beta 1, this implies m1 must be greater than m2. And this is the m1 okay, beta 2 is greater Beta 2 is bigger, right? Beta 2 is, so M2 should be small and M1 should be, and the option is saying M1 is greater. Right here the option is actually M1 greater than M2. Let me just check. Yes, so this means M1 greater than M2. B option, this is also correct. Next, from central maxima, third maxima of lambda 2 overlap with fifth minima of lambda 1. So let's check for C. So third maxima of lambda 2, so y will be equal to what? 3 lambda 2 into capital D by small d, that is equal to 1800 into capital D by small d. This will be the separation. And fifth minima of y1, so that will be equal to how much? Fifth minima means it's 2n minus 1 and n or equal to 0. It's central and first basically. So this is 2n plus 1, let me write it, into lambda divided capital D by small d, and here n is equal to 0 will be the first one. So n is equal to 1 will be the second one. N is equal to 4 will be the fifth one actually. So 4, that means 9 into lambda, it's just 1 second, from central maxima, third maxima of lambda 2, okay, and fifth minima of lambda 1, fifth minima, okay. So n is equal to, alright, divided by 2 is also there here. So that means it's 9 into 400 into capital D divided by 2 into small d, and this comes out to be 1800 capital D by small d. So that is also means these two distances are coming out to be same. So this means these will overlap. That's correct, means C is also right option. Then the angular separation of fringes of lambda 1 is greater than lambda 2. So what is angular separation? Angular separation is equal to what? Lambda by small d. So this implies small d is constant. So let me write angular separation is directly proportional to lambda, and here we know actually lambda 1 is less than lambda 2. So angular separation for lambda 2 will be greater. So angular separation of fringe lambda 1 is greater. No, it will be angular separation of lambda 2 will be greater. So means this is not right. So here correct options is A, B, C, and D is not right. This is correct, and this is correct. This is the problem, and it was asked in year 2014. Let's see the next one. Okay, next question here. Using the expression 2d sine theta equal to lambda, one calculate the value of d by measuring the corresponding angle theta in range 0 to 90 degree. Wavelength lambda is exactly known and error in theta is constant for all values of theta as theta is increases from 0 to 90 degree. Then absolute error in D remains constant, absolute error in D increases, fractional error in D remains constant, and fractional. So we need to check for fractional and absolute error in D by using this relation 2D sine theta equal to lambda. So first let's calculate the absolute error and fractional error in D. So I'm taking L or natural log ln2 plus ln D plus ln sine theta equal to ln lambda, because it's clearly mentioned lambda is exactly known, so means there is no change in differentiating it. 0 plus delta D by D plus this is a cos theta by sine theta into delta theta equal to 0, and taking the magnitude, this is delta D by D equal to magnitude only This is delta theta divided by tan theta, right? This is fractional error. And absolute error, so that will be equal to delta D is equal to D delta theta divided by tan theta. It's also clearly mentioned the error in theta is constant, means this is constant. We are measuring delta D with measuring theta. So now let's check for it. So this is here, this is constant, this is fractional error which is inversely proportional to tan theta. As theta increases from 0 to 90 degree, so tan theta will go from where? 0 to infinity. Clear? So tan theta increases means this fractional error 0, it's 0, so means fractional error will be maximum infinite 1 upon infinite, it will be 0. So what means fractional error decreases? Fractional error decreases, right? And absolute error will also decrease. Will also decrease. We can check the option now. Absolute error in D remains constant, no. Absolute error in D increases, no. Fractional error in D remains constant, no. And fractional error in D decreases. This is the right option. That is next question. It was asked in JEE IIT Advanced 2013.